Alright my friends, we are in video number 4 and we're moving pretty quick, and I kind of wanted to show you at least how we can begin to at least graph these. So we kind of saw in video 3 how to go from a graph to a table. Now let's go backwards. How can we go from like a table to a graph, or an equation to a graph? So a student wanted to save money. She's putting 3/4 into a container every day, and you see we already did the work for you here. Notice how we're just adding by 3 every time. We're just adding by 3, and remember, if we wanted to figure this out, just real quick recap, well, what's 3 times 4? Well, 3 times 4 is 12, because 3 plus 3 plus 3 plus 3 is 12, right? Multiplication is a shortcut for addition. So if I want to find out how much there's in 120 days, we just do 3 times 120, and that's going to be 360. And we put that here. Well, what if it's x? X being, it could be any day. Well, just 3 times x. Therefore, we get the equation to be y is equal to 3x, right? 3 multiplied by x. Okay, well, let's graph this. Well, we know it starts at 0, 0. Okay, and when x is 1, our y value is 3. So when x is 1, our y value is 3. So I'm just graphing these. When x is 2, it's 6. And when x is 3, it's 9. Okay, so I'm just graphing this. And now the question to you is, well, what do you notice the connection is from this equation, the 3x, and the graph? Well, I'm hoping that you notice, since this is x and this is our y value, you'll notice that, well, in order to get from here to here, you can think about it in a couple ways, but essentially you're just going up 3, 1, 2, 3, which is represented by this adding by 3. We're going up 3, so up 3 over, well, how much are we adding by on the x-axis? Well, we're going over 1, so 3 over 1, right? Basically, what's 1 plus 1? That's 2. 2 plus 1, 3. So notice how we take into account what we're adding on the y, but we also take into account for the x. And that means from here, well, that means we're just going to go up 3 over 1. So up 3, boom, over 1. Up 3 over 1. So when we write our equation, this is 3 over 1 times x. But again, when we did our equations, what's 3 divided by 1? It's just 3, right? 3 divided by 1 is 3, so it's just 3x. And that's why you can think of this as having kind of an invisible 1 underneath. So let's go ahead and take a look at this over here. Okay. A student wanted to save money. She's going to put 3/4 in a container every 2 days. So big key idea here is every 2 days and not every day. So if x represents the number of days, well, when it's 0, how much money does she have in there? Well, right now she's going to have 0. But is she going to put money in the container every single day? Right? She's starting with 0, and then she's going to put 3 when? Well, she'll put 3 in every 2 days. So instead of being 1, 2, 3, 4, etc., this will be 2, because this x represents the number of days and y represents the total quarters. Okay, so when she puts 2, when 2 days passes by, how much does she put? Well, she puts 3, so 0 plus 3 is 3. Okay, when 2 more days passes by, so 2 plus 2 is 4, how much are we putting on the y? Well, we're still going to add 3 every time, so this is 6. Okay, now this would be 6, and now this would be 9, right? Just adding by 2s on the x-axis, we're adding by 2, and over here, we're adding by 3. So 8, this is 9, 10, 11, 12. So let's go ahead and graph this. 0, when this is 2, we're going to go up 3. There it is. And then when x is 4, we're going to go up 6. I'm just looking at the table. And when x is 6, we're going to go up 9. Which is right over here. All right, and we can go ahead and graph this to be such. Okay, well, what's the connection here? Let's clear that out, because that shouldn't even be here, because we want to write an equation here. So let's check this out, and don't even worry about this actually. Okay, I just want you to understand the graphing and the connection. Well, check this out. What would be the equation? Well, the equation would be, well, how much are you going up by? Well, you're going up by 3, so 3 over, and then how much? What's happening to the x's? Well, it's not every day, it's every other day. So we go over 2, right? That's what the table over here. So 3 over 2 times x. And that's what we do every time. Anytime we want to graph something with the equation, this is how it would work. We can plot the points, and then we can go ahead and make an equation here. And let's see how this makes sense. If I plug in 2 for x, right, on the second day, well, there's a multiplying of 2 and there's a division of 2. These are going to cancel out. and we're left with 3, which is exactly what we get right there. Okay, so let's go ahead and take a look at a couple more, and let's see if we can begin to understand these. Here's a problem where we're going to put 3/4 in a container every single day, but she currently has 14, so she's starting with 14. So let's go to 0 and let's go to 14, which is right there. And how much? It's every day, so we're adding by 1 over here, right? Just adding by 1. But what are we adding by over here? Well, we're adding by 3 every time. Okay, and notice how our equations can be any of these two. Well, we're starting with 14, and then we're adding 3/4 every time, so 3x. Or we could write this as y is equal to 3x plus 14, but you just have to keep in mind that you're starting with the 14 here, and then you're going to add 3x. So this may look a little different, but it doesn't matter. It's still going to give us the same equation. Well, let's graph this. When it's 1, it's 17. So when it's 1, it's 17, and when it's 2, it's 20. Okay. Well, how does our equation help us? Well, look at our equation. This tells me what I'm starting with, 14. So I started 14, and this tells me I'm adding by 3. And because there is no number underneath it like this, we assume it's 1. So that means 3 over 1. So we just go up 3, 1, 2, 3 over 1. Boom. Up 3 over 1. 1, 2, 3, up 3 over 1. And then we can begin to graph this. Notice how I'm not going to the negative sections. Why? Well, we're talking about quarters. She's putting money into the quarter. We don't expect her money to decrease if she's putting it into the container. That's why we shouldn't have a line that extends down in this direction. Okay? So let's go ahead and look at this. Given the equation below, how can we graph this? Well, what can we do? Well, we can create a table if we want. But hey, why not? Let's rewrite this real quick to be y equals 4 plus 2x. I kind of like to visualize it like this. I'm starting with the 4. So I'm starting with the 4. And how much am I adding by every time? If you wanted to, you can make a table. When it's 0, we start with 4. Well, notice, is there any number over here underneath the 2? No. So we just assume it's like a 1. So if I want to make a table, I can go 1, 2, 3. Okay. And how much are we adding by every time? Well, the multiplication of 2 is a shortcut for addition. And since it's plus, that means we're adding by 2. So 4 plus 2 is 6, 8, 10. And then we can graph it, but no need to, right? Because let's think about it. We're starting with 4. We're going to add 2 every single day. So just go up 2 over 1, up 2 over 1, up 2 over 1, and we're going to get this line. Okay, because it's an equation and I'm not telling you a scenario problem, we can now go down to over 1, and we can get the entire line, which will have negative and positive values like such. Let's take a look at this one here. All right, well, let me rewrite this as, just because you'll see equations like this, but I like to just be able to rewrite them as 5 plus x. But it don't matter. You can think of it as, okay, here's my starting value, 5, and then what am I always going to be adding by? Okay, so here we go. Well, what's the number in front of the x since it doesn't show it? Well, before we had like a 2x, like that, right? Well, this is just x. Well, whenever you see an x, there's like an invisible 1 there. So you can think of maybe just putting like an invisible 1 there. So you're starting with 5. Let's go here, and you're going to be adding 1 every time. So you're going to go up 1. There's no number under here, so we assume it's 1. So we go up 1 over 1, up 1 over 1, up 1 over 1, and we can do the same thing, down 1 over 1, down 1 over 1, just to complete our line. And there it is. Boom. Okay, so you can see this is just an efficient way for us to graph this. So again, if it's helpful, you can rewrite this as 1 plus 2 over 3x. Okay, we're starting with 1, so I'll put 1 here. But you can just see the 1 is right there. It doesn't have an x. It's a y-intercept. And well, what does this mean? Well, we're going to go up 2 over 3. This is our constant rate of change, or our average rate of change. So up to 1, 2 over 3. 1, 2, 3. So right here, go up 2 and go 1, 2, 3. And you can do the same thing down below. Go down 2 over 3. And we can get our line like such. And there it is, done. Nothing else for us to do. We're just interpreting the equation and helping us quickly sketch it without having to make a table. But you can if you want to. Let's try this one out. Well, this is y equals negative 5 plus 3 over 4x. So we're starting at negative 5. So negative 1, 2, 3, 4, 5 right there. This is negative 5. And we're going to go up 3. So up 3 over 4, which is right here. We're going to add. So that means we go up 3. 1, 2, 3, up 3 over 4. 1, 2, 3, 4. Up 3. 1, 2, 3 over 4. 1, 2, 3, 4. There it is. And we can do it on the other way. Down 3. 1, 2, 3 over 4. 1, 2, 3, 4. And we get this line right here. And we can quickly sketch it. Okay. Here's another thing we could do just to show you. Actually, no, we're good. Don't even worry about it. We'll call it a day here. All right. And hopefully this helps you. And, you know, you're feeling pretty confident with what we're learning. If not, make sure to always stop by.